VariCity is a visualization relying on the metaphor of the city to exhibit zones of high-density variability implementations in a single object-oriented codebase. In such systems, variability is implemented using traditional techniques from the language, such as inheritance, overloading of constructors and methods, and design patterns. A part of the codebase concentrating a high density of such implementations denotes a zone of interest in terms of variability, as it is very likely to be a zone of variability management. In VariCity, we aim to focus the user on classes making heavy use of variability implementations. Therefore, the dimensions of every building represent the class-based metrics related to variability, being the number of variants at method level. A tall building shows an important number of method overloads, whereas a large building shows an important number of constructor overloads. Moreover, buildings in color on the visualization represent classes defined as hotspots, meaning that they are part of dense zones of variability. Finally, buildings with an additional crown exhibit design patterns. Streets depart from a building to represent a usage relationship between this class and every other class whose building is on the street. Inheritance links are represented as aerial links between buildings and additional usage relationships as underground streets. These relationships are only displayed when hovering or clicking a building. This enables the user to see this information if needed, while the hotspot coloring and main streets for usage bring the most important information first. Entry point classes, being points of interest of the system, are aggregated on a red street. Starting from them, classes using or being used by the entry points up to a certain level are showed on the visualization, using a placing algorithm minimizing the distance between related classes. The entry point classes, the orientation of the usage relationships considered, and the maximum level of usage shown are pre-configured and can be adapted while browsing the visualization to tailor it. We illustrate the capabilities of VariCity through two scenarios. In the first scenario, the newcomer onboards on the NetBeans IDE codebase and needs to use the Java Platform API, which configures the version and location of Java to be used when building and running a project. To better understand the operation of the API, the newcomer thus needs to have a global vision of the structure of the usage and inheritance relationships between the classes. To this effect, the expert configures the visualization to use the endpoint of the API, namely the Java Platform class, as the entry point of the visualization. Both classes using and being used by Java Platform on 5 levels are shown to have a first overview of the classes being closely related to the endpoint of the API. A neighborhood of tall and colored buildings detaches from the other buildings in the city, showing to the user zones with classes heavily using variability implementation techniques. By zooming and spanning the visualization, the user can focus on this precise part of the city. The different implemented design patterns are distinguishable due to the spatial shape of their buildings. The two abstract test generator classes in the JUnit and TestNG packages are not only design patterns but also hotspots, giving a strong intuition about the relevance of the potential identified variation points. In fact, these classes allow to generate test code for two different unit test libraries, JUnit and TestNG, and are the variants of the cancelable task interface. In a second scenario, the newcomer onboards on JFreeChart, a Java library allowing to draw different types of charts, and is asked to implement a new type of chart in the library. Contrary to the first scenario, the newcomer aims at adding a new feature to the codebase. Thus, she needs a more fine-grained understanding of it, as, for example, the classes used by the other charts that she might also need to use. The expert thus configures the visualization to use as entry points JFreeChart, being the endpoint of the library used by the users to create plots, and plot, the superclass of all classes implementing a different type of chart. As the goal is to display which classes are used by these two entry points, the usage orientation is set to out and the usage level to 2. By hovering over plot, the newcomer can see the different displayed subclasses of the class. To add another type of chart in the library, she will need to implement a new subclass of this class and needs thus to have an overview of the classes used by these subclasses. To do so, the user adds the two most variable ones, being XY-plot and category plot, as entry points. The shape of the city changes to display the usages related to each entry point in separated neighborhoods, allowing to better visualize if a particular entry point is the starting point of a dense zone of variability implementations, and if a class is related to a certain degree to two entry points with underground streets. An important number of classes making heavy use of variability implementations is visible, and are directly used by XY item renderer, itself related to both XY plots and classes related to category plot. Given these characteristics, the newcomer may need to reuse it to implement its features, and thus can add it as another entry point to visualize its usage if needed.